The universe's default state is a continuous geometric field held in strict equilibrium. There is no discrete matter here, only excitations bounded by non-commutative geometry. The mathematical challenge is taking these continuous differential probabilities and translating them into fixed, discrete arithmetic structures without losing any informational data in the process. This diagram maps the translation pipeline. On the left, the Dirac operator tracks geometric curvature. It passes through the intertwining operator, mapping the continuous spectrum into the automorphic domain. The output is the Hecke eigenvalue equation. The data freezes into discrete integers, represented by lambda p. This mechanism functions as a strict rendering engine. It continuously compiles raw geometric curves into stable, filtered arithmetic data. To connect this abstract arithmetic to physical mass and pressure, we use the classical stress-energy tensor. This is the standard physical matrix used to track energy density, momentum, and shear stress across spacetime. The Adelic Langlands Program parameterizes these physical values. Energy density, momentum, and shear stress are tightly bound by a single unified sum over the global Adel ring. Thus, the tensor satisfies a strict Adelic conservation law. Spatial stresses are perfectly counterbalanced, maintaining a zero divergence equilibrium. To observe this universe, we must physically break this mathematical symmetry. Without a disruption to the gauge, the Frobenius elements remain algebraically locked, freezing the field into a rigid, non-vibrating configuration. Because the field exists only as a set of structural data symmetries across the Adel ring, it lacks a measurable classical profile. In this state, the universe is arithmetically locked and entirely devoid of measurable classical forces. An observable mood activation is a localized physical phase transition that intentionally breaks the global gauge coherence of the field. We model this through Galois Deconfinement. The absolute Galois group fractionates locally along its inertial subgroups, meaning the local Frobenius elements are no longer forced to match the global arithmetic path. Applying the observer deconfinement operator initiates the physical uncoupling of these components. The immediate mathematical consequence is the off-diagonal momentum terms vanish entirely. The matrix completely diagonalizes. The unified spatial shear stress on the diagonal fragments into isolated prime-specific pressure sheets, each exerting pressure independently. The local energy density component at the top left is now completely decoupled from spatial kinetic transport. It fluctuates as a standalone classical scalar. The act of observation physically shatters a unified mathematical field into independent, vibrating classical forces. These newly uncoupled prime pressure sheets do not remain stable. They immediately interact as open quantum systems against the thermal background metric. The Caldera-Leggett master equation tracks quantum phase destruction through this phase damping term. Extracting the decoherence rate reveals an inverse logarithmic scale based on the prime. Plotting this, small primes show steep decay, solidifying instantly. Hyper-large primes approach zero, persisting as a long-lived quantum tail. The entire cascade scales linearly with the background temperature. A highly energetic thermal background accelerates the uncoupled components toward instantaneous classicalization. Observation triggers a multi-scale collapse. Fundamental spatial boundaries harden immediately, while complex parametric symmetries take vastly longer to finalize. The sudden violent hardening of these prime pressure sheets generates a massive localized acceleration of mass energy. Mathematically, this accelerating energy maps directly to the second time derivative of the localized Adelic quadruple tensor. This equation defines the linearized gravitational wave ripples, driven by the sum over decohering primes. Plotting strain over time reveals an immense high-amplitude spike exactly at observation, linked to the collapse of the lowest primes. Following this shock, hyperlarge primes emit a weak, persistent hum. The total radiated power carried away by these ripples is quantified using the Isaacson effective stress-energy tensor. The abstract informational entropy from the initial Adelic state is physically purged out into the surrounding universe as gravitational radiation. The energy density of these localized gravitational ripples acts as a secondary curvature source, creating a nonlinear feedback loop that permanently alters the background metric. To track how these deconfined fields warp the coordinate space they inhabit, we move past linear approximations and use the nonlinear Adelic back-reaction field equation. This macroscopic field equation injects the Isaacson tensor directly back into the Einstein field equations. This permanently alters the Christoffel symbols and the Riemann curvature tensor, depending entirely on localized prime decoherence rates. This massive initial energy surge creates a temporal curvature pinch, severely distorting the lapse function and inducing intense local time dilation at the core. The abstract arithmetic data is actively fighting against and physically bending the time and coordinate space of the observer. We evaluate the final configuration by integrating the semi-classical expectation value of the quantum stress energy tensor over the full evaporation time. This integral yields the quantum metric memory effect. By tracking a fourth power sum over the Adelic-Hawking power spectrum, it couples distinct prime trajectories into a cross-coupling matrix over the resolvent poles. Plotting this spatial result, the low prime shot creates a discontinuous step, permanently locking the local grid into an elevated plateau. Off-diagonal terms then deposit a self-similar fractal pattern on top. The background spacetime never returns to a smooth, flat continuum. It is permanently discretized, locking into a rigid, unyielding architectural form. Observation acts as a compilation engine, permanently burning the arithmetic of the Adelic Langlands Program into the physical, macroscopic topology of the universe.